Hello friends, in this video we will look at the IP addressing and subnet. Generally this is a confusing concept for networking students, so I will try to make the concept as simple as possible, and we will understand what is IP addressing version 4, what are the various classes of addresses available, and how to design a subnet. That means how to set aside how many bits will be allocated for a particular subnet and how to design the subnet mask. So let us begin. So we have the IP version 4 addressing and subnetting. So first of all, what is an IP address? A IP address is a 32-bit number which is written in dot notation. That means we have 32 bits of numbers which are separated by dots after every 8 bits. Like you can see here, this is a string of 32 bits. So we have put after every 8 bits 1, 2, 3, 4, 5, 6, 7, 8. After 8 bits I have put a dot here. So after every 8 bit there is a dot, and we can convert each of these 8 bits into decimal numbers. Like we can see here, this number, same number has been converted into decimal, and we have written here separated by dots. So this is an IP address, and internally within the computer it looks like this, the binary format. So this IP address is used to identify a machine uniquely over a network, and it is like a name that we give to our computer. And in a network, the machine is identified by this address. All the messaging takes place using this address, and it is the network layer or a router with the, a network device with layer 3 can see the IP address. So in IP address version 4, there are 4 classes of addresses. The network addresses have been divided into 5 classes. The classes are based on the range of numbers that are allowed. For example, in a class A address, the addresses begin from 0 in the first octet and up to 127 in the first octet. So it can range from values from 0 to 127. So always the leftmost bit in the first octet of the IP address is going to be a 0. Because if this number will become 1, then the number is going to become 128 plus whatever are the following bits. So if the first number is 0, that means the value will always be less than 127, or up to 127 is possible. And the first 8 bits are used to identify the network. That means here 127 will identify the network, and all the addresses from this to this, the remaining 3 octets, they are being used to identify the host, that means the machine. So how many hosts are possible? These are 8, 8, 8. That means 8 3s are 24. So 2 raised to power 24 hosts are possible within a class A address, where the first octet or the first combination of 8 bits is going to identify the network, and the remaining 24 bits is going to identify the host machine. Similarly, we have a class B. In class B, we have addresses from 128 to 191. And how do you identify? The first 2 bits in the class B are 1, 0. 1 will make sure that the value is larger than 128, and 0 will identify, 1, 0 together will identify a class B address. And here the network ID, that means the network is identified by the first 16 bits, and the last 16 bits will determine the host ID. So this is an example. So there are how many hosts are possible in a class B address? 2 raised to power 16 hosts are possible, out of which one is the loopback address and one is the self address, network address. So what is a loopback address? Loopback address is 255, where we have both the octets being set to 255 and 00 octet that will belong to the network ID. Then in the class C, we have from 192 to 223, and a class C network is identified by 110. in the first three bits of the network address. Out of the 32 bits, the first three most significant bits will be 110. And here 24 bits are used to identify the network and only 8 bits are used to identify the machine over the network. Then we have the class D. It is identified by 1110 in the most significant bits, and the remaining 28 bits are used to identify the multicast addressing. Now, what is multicast? In which more than one machines are addressed using the same address. And then we have the class E address. In the class E address, it is reserved for special purpose, and as such, it is not used in any organization, and it's identified by a a quadruple or a 4 times 1 in the most significant bits of the IP address. I hope the IP address is clear to you. Now let us move on to identifying the various network addresses, and also how subnet can be created out of a major IP address class. Now, if the first bit is 0, then it is a class A address. If first bit is 1, then it is, and second bit is 0, then it is class B. If the first two bits are 1 and the third bit is 0, it is a class C, and so on. And you can even remember these ranges which are given over here in the slides, and you can remember these so that you can easily identify the class of a given IP address. Now we come to subnet. Now, first of all, we have to understand what is a subnet. Subnet is when a main IP address, suppose I assign a network ID of 124.165.8.0. This is the network ID. So when I assign this network ID, that means all the machines from the range of 224.165.8.1 onwards till 224.165.8.255, all these machines, they belong to one network. Now what happens, sometimes if it is a small organization, they don't need 255 addresses, they need only 5 addresses or 10 addresses. So this will lead to wastage of so many addresses. So what we can do, we can create a subnet where we configure the router into believing that not only the first 3 octets of the IP address, but also some part of the 4th octet also identifies the network. This is what we have in the subnet, where we create a sub network out of the main network class that we have. So how many nodes are possible? Maximum in a class C address, we have 254 nodes possible. Why not 256? Because 0 in the last octet is the network ID and the 255 is the loopback address. So therefore, 256 minus 254 maximum nodes are possible. Now suppose you want only 10 nodes in your network. So how many bits are required? You will require, the range is 2 raised to power 3 is 8 and 2 raised to power 4 is 16. So I need 10 nodes. Therefore, what I will choose is, I will reserve 4 bits for the subnetting. How I have selected this? Because I need 10 unique addresses, and out of the octets, that is all the 8 bits that are available, 4 bits will be dedicated to the network and 4 bits will be dedicated for the host ID, and therefore I need 4 bits to represent 10 nodes. Minimum 4 bits are required, because with 8 bits, 3 bits I can get only 8 addresses, but since I need 10 addresses, so I will go to the higher choice and I will select 4 bits so that I will get 16 addresses maximum. So this is a practice question. Which class address will be required to create a subnet of 120 machines? How many bits are required in the subnetting address? Now since we need 120 machines, so again we will raise to the power of 2. So 2 raised to power 6 is 64 and 2 raised to power 7 is 128. So this 7 is better because 128 minimum machines, maximum machines I can configure using 7 bits. So 7 bits will be used for creating the subnet. And class C is sufficient for this because only 120 machines are required. Now, what is a subnet mask? When we create a subnet, we have to define the subnet mask also, so that we will include some portion of the last octet in the network ID itself. So, if I have an IP address like this 232.165.32.1, now I want to subnet for 16 machines. So, I need 4 bits in the subnet mask. So, what I need is last 4 bits in the subnet mask should be 0 and remaining all bits should be 1. So, if I want to set all last 4 bits to 0, then if I convert this particular value into its corresponding decimal number, I will get 240. So, all the entries will be 255 because I want 1 in all the positions. And in the last octet, I will place 240 so that only the 4 bits will be used for the network purpose and the remaining 4 bits will be used for the host ID. I hope this video is useful to you. And the subnetting that I have explained here in very simple manner is clear to you. And if you have any doubts, please feel free to ask in the chat window. And I look forward to your queries and your feedback, as that is important to me. You can like and share my videos and subscribe to my channel. Thank you very much.